Hello, this is Dr. Mode and welcome back to ICP class today. We're still in the chapter on energy sources, but we are now starting section 3, which is about renewable energy. Our scripture verse for today comes from Revelation chapter 21, verses 6 to 8. And he said to me, "It is done. I am the Alpha and the Omega, the beginning and the end. I will give of the fountain of the water of life freely to him who thirsts. He who overcomes shall inherit all things, and I will be his God, and he shall be my son. But the cowardly, unbelieving, abominable, murderers, sexually immoral, sorcerers, idolaters, and all liars shall have their part in the lake which burns with fire and brimstone, which is the second death." Okay, we're halfway done with chapter 8, so we're starting the second half today. If you look at the graph on the right, you can see a plot that goes from 1950 up to about 2017. This is the energy that is used in the United States. So what you can see is that it's broken down into 5 different groups. At the bottom, we have coal. Above that, we have natural gas. In the middle, we have petroleum. And then in the orange, the second from the top, we have nuclear power. And then at the very top, we have in green the renewable sources. So the chapter or the section today is about those renewable sources. So what you can tell is the renewable sources of energy back in 1950, the thickness of that green part is not very thick, so it's smaller there, but now it's quite a bit thicker, so it's been increasing over time. And the prediction is that renewable sources are going to continue to increase and become more and more a significant part of the energy that we use in this country. Okay, so there is 1,000 times more energy that shines on the United States from the sun every year than we can use. The sun provides virtually unlimited energy, and only about 1% of our energy comes from solar. So in this picture, you can see that there are solar panels covering this roof. Those are known as photovoltaic cells or solar cells, and of course they convert radiant energy from the sun directly into electrical energy. Okay, so if you look at the figure on the right, what we have is a layer stack diagram of how a solar cell is constructed. So let's go through these 6 parts. Well, we have sunlight coming in from the top, and the first thing that it hits, labeled in A, is the cover glass or some sort of protective surface that protects the rest of the layers. The second one is an anti-reflective coating. We want the light not to reflect away. We want the light to go in to the remaining layers, so this coating helps that to happen. Then what we have in the one labeled C is a contact grid. This is basically going to be the top electrode. Okay. Then we have the next 2 layers, D and E. We have an N-type silicon semiconductor, and then we have a P-type semiconductor. So those 2 semiconductors are where the magic really happens. The light goes there, and it creates like an electron hole pair, and by hole I mean you have basically a positive charge or the absence of an electron, and the solar cell striking that interface causes this to happen, and you have this charge separation that happens, and then the charge basically goes up to the electrode in layer C, and then layer F is the back electrode. So you have this electron hole pair, they start to separate, and they get up to layer C and layer F, and that produces an electric current. So solar is becoming very cheaper and cheaper. It used to be extremely expensive and not very practical, and now we're seeing more and more of it because it's becoming cheaper and cheaper. It's not quite as cheap as fossil fuels yet, but it is getting there. Another form of solar energy that doesn't use a photovoltaic cell is a parabolic trough. And you can see those pictured here. Now these are facing down, they're not facing the sun at this time, but what you want to notice is that the troughs are highly reflective, and what they do is they concentrate the power of the sun onto this tube that runs in along the middle there. This tube is filled with water, and what happens is this concentrated solar energy will turn that water into steam, and then that steam will be used to turn a turbine. Just like fossil fuels can be used to turn a turbine, this is another way that this can be done. Now, the largest power plant that uses this is located here in the United States. It's in the Mojave Desert in California. So another renewable source of energy is from water. Okay, so we've talked about how steam can be used to turn a turbine, but rapidly moving water can also be used to turn a turbine. So what you have in this picture here is you have an old-time water wheel. These were typically connected to mill houses where they would grind grain or something like that. And what you have is you have water flowing in from a creek that's at a slightly higher elevation, and it flows in and it turns this water wheel, which then is converted into mechanical energy that's used inside that building that you see there. So today, in more modern times, dams are used to store up a bunch of potential energy of this water that's held in the reservoir side behind the dam, and that water that can then be directed through the dam through tunnels can be converted into electrical energy. Okay, so this use of a dam is called hydroelectricity, and it's defined as producing electric current from moving water. So hydroelectric power is about twice as efficient as the fossil fuel power plants. So it's approximately 70% efficient, and they are a very good source of electricity, but they do have a few problems. One is that they can interrupt fish migration because fish typically swim upstream to lay their eggs, and if you build a dam and you block those rivers, then it can interrupt that fish migration and cause problems with different species.